Module 2, Data Modeling. Overview of data modeling. Data modeling is a critical step in the data architecture process as it involves designing and defining the structure, relationships, and attributes of the data. Data models provide a visual representation of how data is organized and stored, and serve as a blueprint for creating and managing databases or other data storage solutions. Here's an overview of the key concepts and types of data models used in data modeling. 1. Entity Relationship model. The ER model is a widely used data modeling technique that represents the entities, objects, things, or concepts in a system and their relationships. Entities are represented as rectangles, and relationships between entities are represented as lines connecting the rectangles. Attributes, or properties of entities, are represented as ovals within the entity rectangles. ER models are used to define the structure and relationships of data in relational databases. 2. Relational model. The relational model is a data model that represents data as tables with rows and columns, where each row represents a record and each column represents an attribute. Tables in the relational model are related to each other through keys, which are used to uniquely identify records in different tables. The relational model is widely used in relational databases, which are the most common type of databases used in organizations. 3. Dimensional model. The dimensional model is a data modeling technique used in data warehousing and business intelligence (BI) applications. It represents data as fact tables, which store quantitative data, and dimension tables, which store descriptive data. Fact tables and dimension tables are related to each other through keys, and are used to model multidimensional data for efficient reporting and analysis. In conclusion, data modeling is a critical step in designing the structure and relationships of data in a database or data storage solution. Different types of data models are used to represent data in different ways, depending on the requirements of the application or system. Conceptual, logical, data models. Conceptual, logical, and physical data models are different stages in the data modeling process, and each serves a specific purpose in designing and implementing a database or data storage solution. Here's an overview of each type of data model. 1. Conceptual data model. The conceptual data model is the highest level data model that represents the overall structure and relationships of data in a system from a business or user perspective. It describes the entities, their relationships, and the attributes at a high level of abstraction, without going into details about how the data will be stored or implemented in a database. The conceptual data model is used to establish a common understanding of the data requirements among stakeholders and to guide the development of the logical and physical data models. 2. Logical data model. The logical data model is the next level of data modeling, and it provides a detailed representation of the data requirements of the system in a technology-independent manner. It defines the structure and relationships of data using a standardized notation, such as an entity relationship, model, relational model, or other data modeling technique. The logical data model includes entities, their relationships, attributes, primary and foreign keys, and other constraints, but does not specify how the data will be physically implemented in a database. The logical data model serves as a blueprint for designing the physical data model and creating the database schema. In summary, the conceptual data model represents the high-level understanding of data requirements. The logical data model provides a technology-independent representation of the data structure and relationships, and the physical data model defines how the data will be physically implemented in a database. These three types of data models are used sequentially in the data modeling process to ensure a clear and consistent representation of data requirements, design, and implementation in a database or data storage solution. Data modeling techniques and tools. Data modeling is a crucial step in the data architecture process, and there are various techniques and tools available for designing and representing data models. Here are some commonly used data modeling techniques and tools. 1. Entity Relationship model. The ER model is a popular graphical technique used for conceptual and logical data modeling. It represents entities as rectangles, attributes as ovals, and relationships as lines connecting the entities. The ER model is used to define the structure and relationships of data in a visual and intuitive way, and it can be used to create conceptual and logical data models. 2. Unified Modeling Language, UML. UML is a standardized visual modeling language used for modeling software systems, including data models. UML provides a rich set of notation and diagrams, such as class diagrams, object diagrams, and activity diagrams, which can be used for representing data models at different levels of abstraction. 3. Data flow diagrams, DFDs. DFDs are a graphical technique used for representing the flow of data within a system. They show the processes, data stores, data flows, and external entities in a system and their interactions. DFDs can be used for modeling data flows and data transformations in a system, and they can be used for both conceptual and logical data modeling. In conclusion, data modeling techniques and tools provide a structured approach to designing and representing data models, and they are essential for creating conceptual, logical, and physical data models that accurately represent the data requirements, structure, and relationships of a system. The choice of data modeling technique and tool depends on the specific requirements of the system, the type of database or data storage solution being used, and the preferences of the data architects and stakeholders involved in the data architecture process. Thanks for watching. For more information, like, comment, and subscribe our channel.